All right, so number 6, I have 2 zeros. We're going to find all 2 of those. Now, if you have x to the second, you don't even have to do the whole possible rational roots because you can just plug into the quadratic formula, right? Now, if I could factor this, then I would do that, but there's nothing that multiplies to make 1 and adds to make 4, so I can't factor it. So I know that the A is going to be 1, B is -4, and C is 1. So I have x is equal to the opposite of b, so 4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so we'll start with underneath the root first, because if it's a negative number, then it's going to give us issues, right? So this would give me 16 minus 4, so that's actually going to be 12 all over 2, but I'm going to have to reduce that root. So you can either do it by hand and realize that this would be the square root of 4 times the square root of 3, which would be 2 square roots of 3, or you can plug it into the smaller calculator and it will give that to you. So we get 2 square roots of 3, and then I realize that all of these will divide by the 2, right? So 4 divided by 2 gives me 2, and 2 divided by 2 is 1, so just 1 square root of 3. So my answers are 2 plus or minus the square root of 3. Those are my 2 zeros. And then I have to write that as a product of linear factors. So here's where we have to do a little bit of thought here. If I change the sign, this is 2 separate things. I have a 2 plus the square root of 3, and then I have a 2 minus the square root of 3. So you have to think about this as it's like x minus all of this. And then x minus all of the other one. So if you distribute that negative, that would give you x minus 2 minus the square root of 3. And then this one would be x minus 2 plus the square root of 3. So essentially all that's happening is you're changing the signs of both of these. Alright, so you know that this is going to change to a negative and this is going to change to a negative. This is going to change to a negative and this is going to change to a positive. So if you think about it like that, makes it a little bit easier to think about. So I have my 2 factors and I have my 2 zeros right there. Alright, so again, we are still finding all the possible factors first. So I'm going to list everything that multiplies to make 80. So we've got 1 and 80. I'm not going to separate them this time. I'll just do 1 and 80. And then it'll divide by 2, so 2 and 40. Alright, it doesn't divide by 3, but it will divide by 4, so 4 and 20. It does divide by 5, 5 and 16. It doesn't divide by 6, doesn't divide by 7, 8 and 10. And then the only thing between 8 and 10 would be 9, and it doesn't divide by 9. Then I'm going to divide all of those by the factors of 3, which would be 1 and 3. Then I have to go through and divide everything. So everything on top divided by 1 would be everything on top. So 180, 2, 40, 4, 20, 5, 16, 8, and 10. Then I have to go through and divide all of those numbers by 3. So I've got 1/3. Then I've got 80 over 3. 2 over 3. 40 over 3. 4 over 3. 20 over 3. 5 over 3. 16 over 3. 8 over 3. And 10 over 3. We had none that repeated, right? These are all of the possible ones. Now, it might seem pointless to like find all of these, but let's say that this equation didn't cross on an integer. Then you would have to use your table and try and figure out which of these fractions it is, right? You wouldn't be able to do that if you didn't know what your possible ones were. So we're going to do like we always do. We're going to go and we're going to graph this and see if we can find somewhere where it crosses the x-axis. All right, so when we graph it, this is what we have, right? So it's only crossing one time. So if I have 3 zeros, that means I have one real, and the other 2 are going to have an I in them because the other 2 are imaginary. But that's not crossing exactly on an integer, right? It's crossing somewhere between 1 and 2. So you're going to need a fraction that's top-heavy, right? So if you look at your options here, okay, all of these are out, right? All these integers. This one's out because it's not top-heavy. It has to be over 1, right? 3 can't go into one whole time. 3 can't go into 2. Okay? So these are pretty much our options, right? And it's a positive, so we know it's not any of the negatives. And you don't want anything that's bigger than 2, so like 3 will go into 80 more than 2 times, right? So that one's out. 3 will go into 40 more than 2 times. 3 will go into 20 more than, I should say, yeah. You don't want anything that's 2 and bigger. You want something less than that. That one's okay. 3 goes into 6 more than 2 times, right? 3 goes into 8 more than 2 times. And 3 goes into 10 a little over 2 times, right? So you've narrowed it down to either a positive 4/3 or a positive 5/3, okay? So we're going to take the 4/3 and the 5/3 and we're going to use our table feature to figure out which number that is. So I'm going to go to the table and I'm going to put in 4/3. And I'm looking for a 0, right? Okay, I didn't get a 0. So I'm going to try the 5/3. Okay, 5/3, I got a 0. So that means that's what I'm going to divide by on the outside of my box. So 5/3 is my only real 0. Now, can you imagine trying to find that number without knowing what your possible options were? All right, so I started with x to the 3rd. I'm not missing anything, so I've got a 3, -5, 48, and -80. So I'm going to drop the 3 and multiply by 5/3. So 5/3 times 3 is 5. Plus a -5 is 0. 0 times 5/3 is 0. Plus 48 is 48. Times 5/3 is 80, which gives me a remainder of 0. So this would be 3x to the 2nd. I don't have an x, and then a 48. So I have 3x squared plus 48 equals 0. I don't need to use the quadratic formula, though, because I can just solve for this x, right? So I'm going to subtract the 48. That gives me 3x squared is equal to negative 48. I'll divide by 3. So x squared is equal to negative 16. Then I will square root, which gives me my two answers, right? And we already decided that these were going to be imaginary numbers, correct? So if this wasn't a negative 16, you might want to rethink your answer. So you have plus or minus. If you square root that negative, that gives you an I. If you square root 16, that is 4. So I get 4i. So my zeros are 5/3 and then plus or minus 4i. Now I have to write that as a product of linear factors. So if I changed the sign of this, right, that would be x minus 5/3. This would be x minus 4i because of the positive, and x plus 4i for the negative one. But I'm going to point this out. I don't want this fraction left here. So normally when we factor, right, we move that bottom to the front. So this is going to be 3x minus 5. And then keep the other two at the back. So we're going to find a polynomial when they give us the zeros. So remember that complex zeros occur in conjugate pairs. So in other words, if 3 plus 4i is an answer, then 3 minus 4i is an answer as well. So if they only give you one of these, then you know that the other one is also an answer. Is everyone with me here? So we're going to let f be a polynomial function, I can't spell, that has real coefficients, where if a plus bi, where b is not 0, is a 0 of the function, then a minus b is also a 0. So it says find the 4th degree polynomial. That means that in the end we should have an x to the 4th as our highest degree that has the real coefficients -1, -1, and 3i. Those are my zeros. But this says I have 4 of them, and they're only giving me 3. But since 3i is a 0, then that means negative 3i is also a 0. So that gives me 1, 2, 3, 4 zeros. So I'm going to write these, and we're going to work backwards, just kind of like we did, like when we get our answer, then we would write them as linear pairs. So then we're going to multiply them together and go all the way back. So if I have -1, that would be x plus 1. And then I have another -1, so x plus 1. Then for the 3i, that would be x minus 3i. And then for the -3i, that would be x plus 3i. So if they say 4th degree, I should have 4 of these parentheses. I should have 4 zeros, 4 parentheses. And now it's just a matter of multiplying those together. I always do the I one first because it should get rid of the i's completely, and then I don't have to worry about them the rest of the time. So I'm I'm going to do these two and get that, and then I'm going to do these two, and then I'll multiply what I have left. So I've got x times x is x squared. And then if you kind of shorthand this, this would be a 1x and a 1x, which is going to give you 2x. And then 1 times 1 is 1. So that's what I get from the front. Then I've got to do this one at the back. So I have x times x is x squared. And then the middle is going to end up canceling because they're opposites, right? So I would have a positive 3xi and a negative 3xi. So I'm just going to not even write that because they're going to cancel. Then do the back one. So -3 and +3 give me -9. I times I is I squared. But I know that that's going to change this to a +9 since this is a -1. So now I have the x squared plus 2x plus 1 times the x squared plus 9. Now I just have to FOIL these two together, and I will be done. So x squared times x squared gives me x to the 4th. X squared times 9 is 9x squared. Then you've got 2x times x squared is 2x to the 3rd. And 2x times 9 is 18x. Then you have 1 times x squared is x squared. And 1 times 9 is 9. So now all I have to do is put it in order and combine like terms. So put your f of x in the front to show that you have your function. I don't have any other x to the 4th. So x to the 4th goes first. And then this is the only x to the 3rd I have. So plus 2x to the 3rd. But then I can put together the 9x squared and the 1x squared to make 10x squared. And then I don't have another x, so plus 18x. And I don't have another number without an x, so plus 9. And we did end up with a 4th degree polynomial, right? We've got our 4 up there. All right, this is a cubic polynomial, so we should have 3 zeros, right? And they've added another stipulation here at the back, and we'll talk about that in a minute. And this is the one I was telling you guys about earlier, where people always have trouble with this part in college algebra, and so it would be a good thing for you to get down now. So 2 of our zeros are 2 and 1 minus I, but I'm missing 1, and that's because if 1 minus I is a 0, so is 1 plus I. So I've got x minus 2, and then remember you're going to have to change the sign of both of these. So you've got x minus 1 plus I, and then change the sign of both of these, x minus 1 minus I. Okay, always do the 2 parentheses that have the I. So you're going to kind of leave the x minus 2 out here to chill, and you're going to multiply both of these trinomials. So you have x times x is x squared. X times negative 1 is negative x. And x times negative I is negative x I. Then the negative 1, so negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And negative 1 times negative I is positive I. And then the I, so you have I times x is xi. I times negative 1 is negative I. And I times negative I is negative I squared. So all of your i's should end up going away, all right? So like this negative xi and this positive xi cancel, and the positive I and the negative I cancel. And then you change that I squared to a negative 1, and a negative 1 times a negative 1 is a positive 1. So if we put this in order here, you have your x squared. You've got a negative x and a negative x. That makes negative 2x. So fix those. And then 1 plus 1 is 2. Then you still have that x minus 2 in the front. So if you have any i's left after you get to that point, then you've got a problem. So now you're going to multiply these two together. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 2 is 2x. And negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times positive 2 is negative 4. Then you're going to combine like terms, so you have an x cubed. You have a negative 2x squared and a negative 2x squared. That gives you a negative 4x squared. A 2x and a 4x, that's going to give you 6x, and then you have minus 4. So if I was just writing the equation, then I would be good to go, right? I'd be done. But they gave me another stipulation. They said that this equation, when I plug in 1, I have to get 3 as an answer. So when I plug in 1 for x, then my y should be 3. Well, if I plug in 1 right now, it's not going to equal 3. So I have to figure out how to manipulate this so that when I do plug a 1 in, I get 3. So I want 3 as an answer. And what I'm going to do is I'm going to figure out what number I'd have to multiply times everything, that when I plug that in, I'm going to get 3. So I've got minus 4x squared plus 6x minus 4. Now, as it stands right now, I have too many unknowns, right? I have an a and then I have all these x's. But what number they wanted me to plug in for x? They wanted me to plug in a 1. So that's what I'm going to do. I'm going to go through and I'm going to plug in a 1 for every x that I have. So I have 1 to the third minus 4 times 1 squared plus 6 times 1 minus 4. So this is all going to give you one number. So if I figure out what I have here, if you plug that in, you're actually going to get a negative 1. So this is a negative 1 times a. So I divide by the negative 1. So a is equal to negative 3. So I just figured out that in this equation, if I want to plug in a 1 and get 3 as an answer, then I'm going to have to adjust my equation and multiply everything by negative 3. So I'm going to take the negative 3 and I'm going to multiply it times every term in my equation. So that gives me f of x is equal to negative 3x to the third plus 12x to the fourth, or second, sorry, minus 18x plus 12. So I've made the equation, I've adjusted it so that when I plug in a 1, I get a 3. Alright, so we're going to find a cubic polynomial with real coefficients. So cubic, that means we should have 3, where your zeros are 3 and 2 minus the square root of 2i. I don't like the I behind the square root. I prefer it in front as 0. So if 2 minus the square root of 2i is a 0, so is 2 plus, I'm going to put the I in front, I square roots of 2 is also a 0. And then we'll deal with this last, right? This just means when I plug in 1, I should get 6 as a result. All right? So I've got x minus 3. And then remember, you've got to change the signs of the 2 and this root. So I've got x minus 2 plus, and I'm putting the I in front of the square root of 2. And then do the same thing with this one. So x minus 2 minus I square roots of 2. So you're going to do the back 2 first and leave the x minus 3 for last. So you have x times x is x squared. X times negative 2 is negative 2x. And x times negative I square roots of 2 is negative x I square roots of 2. So you're pretty much just sticking them all together. Then you have the negative 2 times x, negative 2x. Negative 2 times negative 2 is positive 4. And negative 2 times negative I square roots of 2 would be a positive 2i square roots of 2. And now the last one, I square roots of 2 times x is x I square roots of 2. I squared root of 2 times negative 2 is negative 2I square roots of 2. And then you got to put a little thought to this. So you have a positive times a negative. That means you have a negative. I times I gives you I squared, right? And the square root of 2 times the square root of 2, that would be the square root of 4, which is 2. So I already know I've got xi squared to 2 and a negative xi squared to 2, so those go away. And then the negative 2i squared to 2 and the positive go away. And this one back here is a negative 1, which is going to change this negative 2 to a positive 2. Now I just need to put it all together. So I have the x squared, negative 2x, and negative 2x. That gives me the negative 4x. And then 4 and 2 make 6. Remember, if you have any i's left, then you've got an issue somewhere. Fun stuff. Alright, multiply. X times x squared is x to the third. X times negative 4x is negative 4x squared. You definitely don't want to rush through these because you'll mess something up. And x times 6 is 6x. Then you've got your negative 3 times x squared. So negative 3x squared. Negative 3 times negative 4x is positive 12x. And negative 3 times 6 is negative 18. So combine your like terms, get everything in order. So we have an x to the third, and then we have negative 4x squared and negative 3x squared. That's negative 7x squared. 6x and 12x. That gives me 18x. And then minus the 18. So if I just wanted the equation, then you would just give me that equation. However, I want to be able to plug a 1 into the equation and get a 6 in return. So I'm going to put the 6 out here, and then I'm going to put the a in front, and you're going to plug a 1 in for all of the x's. So I've got 1 cubed minus 7 times 1 squared plus 18 times 1 minus 18. So you would plug that in, and you would get negative 6. So this would be negative 6 times the a. Now you're just going to solve for a. So divide by the negative 6. So a is negative 1. So you're going to take that negative 1 and just multiply it times every single thing that you have up here in your equation that you found. So I've got f of x is equal to, now I'm not actually going to show that, I'm just going to do it. So that gives me negative x cubed positive 7x squared negative 18x and positive 18. Alright, so it says to write that function in a completely factored form. Now if you look at this, it's not x squared, but it is x to the fourth, and then your next term is half of that, so x to the second, and then no x. So I can actually factor that into two binomials. So the rules still stay the same. I have a minus in the back, so I have a plus and a minus. And then I have x squared, because that would give me x to the fourth, right? And then what multiplies to make 20 and subtracts to make 1, that would be 5 and 4, and I want the middle term to be negative, so I put the 5 here and the 4 here. So here's the problem. It wants me to write it in completely factored form with linear terms. These are not linear because they have a squared, right? Linear terms have the biggest power of x to the first. So that means I need to figure out what my zeros are, and then I can write them as linear factors. So I'm going to set both of these equal to 0. and solve for x. So I'm going to subtract the 4. So x squared is equal to negative 4. And then I square root with a positive and a negative answer. So I get x is equal to plus or minus, I'm square rooting a negative, so I know I have an I, and then the square root of 4 is 2, so this would be 2i. And then same thing over here, I'm going to add the 5. So x squared is equal to 5. Square root, now 5 is not a perfect square, right? In fact, it's a prime number, so we can't even reduce it. So I just have plus or minus the square root of 5. So I have 2 zeros here and 2 zeros here, which make up my 4 zeros. So now I'm going to do what we've been doing and just write them as factors. So I have x minus 2i, x plus 2i, and then same thing with your roots. So for the positive root, you would have x minus the square root of 5, and for the negative root, x plus the square root of 5. And now I have 1, 2, 3, 4 factors, and they all have x to the first, so they're all linear. Alright, so they've given us 1 0, and they want us to find all the zeros. So we should have 4 zeros in total, alright? And I'm looking at this, and I know that if 1 plus 3i is a 0, then 1 minus 3i is also a 0. That's all the information I have. So what I'm going to do is I'm going to go ahead and multiply those factors together. So I've got x minus 1 minus 3i, because you have to change the sign of both of those. And then same thing for this other one, x minus 1 plus 3i. So I've got x squared, and then x times negative 1 is negative x, and x times 3i is 3xi. Then a negative 1 times x is negative x, negative 1 times negative 1, positive 1, and negative 1 times 3i is negative 3i. Then we have negative 3i times x is negative 3xi. Negative 3i times negative 1, positive 3i. And then negative 3i times positive 3i would be negative 9i squared. So the 3xi and the negative 3xi cancel. The negative 3i and the positive 3i cancel. And then because this I squared is negative 1, that's going to change this to a positive 9. So I'm going to put all of that together. So that gives me x squared, negative x and negative x, that's negative 2x. And then you have 1 and 9, that makes 10. So here's where I'm at. This is the only information that I have. But if you think about something, let's say I asked you, okay, I want you to take 20, and I'm going to tell you that one factor is 2. So find the other factors. Well, if I divided the 20 and the 2, then I would get 10, right? And I could split that up if I needed to, but I would get 10. So I know that if I took this equation and I divided it by this, then that would give me something I could factor and find the other 2 zeros that I'm missing, right? Because I'm missing 2 of them. So that's exactly what we're going to do. And since this is a trinomial, we're going to have to do long division so that we can figure out what's missing. Alright, so originally I had x to the 4th minus 3x squared, cubed, plus 6x squared plus 2x minus 60. Now the nice thing is that we have 3 terms out here, so that'll make it go pretty fast. So I take the first term and I divide that by the first term. So I've got x to the 4th divided by x squared. And that gives me x squared. Then we multiply. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x to the 3rd. And x squared times 10 is 10x squared. And remember, you always make sure that you're lined up, right, with like terms. Then you're going to subtract that, so you're going to have to go through and change the sign. So this will be negative, this will be positive, and this will be negative. Then add down, so these two cancel. Negative 3x cubed plus 2x cubed is a negative 1x cubed. And 6x squared minus 10x squared is negative 4x squared. And then you need 3 terms right here to match your 3 out here, so you drop down the 2x. Then we go through this process again. Negative x cubed divided by x squared. That gives me a negative x. And then we multiply. Negative x times x squared is negative x cubed. Negative x times negative 2x is positive 2x squared. And negative x times 10 is negative 10x. Then you subtract. So that means this is going to be a positive, this will be a negative, and this will be a positive. The first two cancel. Negative 4x squared and negative 2x squared make negative 6x squared. 2x and 10x make 12x, and I need 3 terms, so I'm going to drop down the negative 60. And then I do it again. Ooh, that's not very bright. Alright, so we have 6x squared divided by x squared. Oh, negative 6x squared. So that gives us negative 6. And negative 6 times x squared is negative 6x squared. Negative 6 times negative 2x is positive 12x. And negative 6 times 10 is negative 60. And if I change all the signs, then that means we get a remainder of 0. Which should happen, right? If we multiplied our 2 zeros correctly in the beginning and did all our math right, we should get a 0. So this is the remaining factor. I don't know why I put a parenthesis around that. So we're going to take that and we're going to actually factor it to figure out what our other 2 zeros are. So I have a minus in the back. That's 1 plus and 1 minus. I have x and x. And what multiplies to make 6 and subtracts to make 1, that would be 3 and 2. And since I want the middle to be negative, I'll put the 3 here and the 2 here. So when I solve by setting these equal to 0, I'm going to get negative 2 and positive 3. Those are 2 zeros, and then the other 2 were the 1 plus or minus the 3i. So there are my 4 zeros.